If you've ever gone on a long vacation, you know the traveling salesman problem. This is a problem where you're going to tour multiple cities and you want to find the fastest or the cheapest or the most convenient route through those cities. Now, this is a classic problem in computer science and in logistics, but what most people don't appreciate is as you add each city, the amount of work that you have to do to solve the problem can double, so it grows exponentially. This makes it a very difficult problem when you have lots and lots of cities. The same problem comes up in planning paths for cutting machinery. This is a piece of steel that we cut using a laser cutter. Mitsubishi makes this beautiful 20 kilowatt laser cutter in which you have a head that carries around the fiber end of a laser. That laser punches through the steel like butter, and we need to plan the motions of this head so that it makes all of these cuts and moves from cut to cut in the fastest way possible. Now, it used to be that the way this machine worked was the head moved into position, stabilized, stopped for a moment, and then you turned on the laser and started making the cut. That can take some time, even though this machine is very fast. Recently, they developed the ability to turn the laser on and off on the fly with microsecond precision. We saw an opportunity when they came up with this technology. Why not have the head be moving all the time so it makes a flying cut, just like an airplane that makes a drop? So the head has to actually move into position where it's moving in the right direction to drop in and make the cut, and then comes right out as if it were landing on an airport landing and then coming back out. Now, it turns out this is a much more complicated version of the traveling salesman problem. In fact, it doesn't neatly fit into the traveling salesman formulation because we have to think about momentum. The head has some mass. We want to have it moving smoothly because any vibration that we produce in the machine makes it less precise. So we developed a generalization of the traveling salesman problem that incorporates momentum and the need to have curved trajectories and the fact that the timing on this trajectory depends a lot on the velocity and mass and where it's moving. After some number of years of struggle, we were able to solve this problem just as efficiently as people can solve normal traveling salesman problems, and we delivered this technology to the company where they incorporated it into the machine. Now, the interesting thing about this is not only do you have to decide which cut to do in which order, but you have to decide where to land and start each cut. So this is a massive, massive problem. Essentially, each one of these cuts is divided into hundreds of points, each of which can be an entry or an exit point. So we have hundreds of thousands of cities to tour with momentum. And yet we can solve this pretty well within about 60 seconds. The proof of the pudding is when we uploaded this software onto the machine, suddenly the machine was able to cut essentially twice as fast, which made it twice as productive and twice as valuable. And I'm told when they went to market with this machine, which is roughly the size of a city bus, it was selling like hotcakes.